All right, so we're going to now look at Packet 8, page 3, and this is problem number 1. So you'll notice from problem 1 through 4 are all square root problems because these functions, you'll notice it's just a square root and it doesn't have that 3 subscript up here. So these are the graphing square roots. And remember, when we're graphing square roots, it's this shape right here, that curve on a graph. So in order to graph this, we need to know what the vertex is. So let's start there. So what we're going to do to find the vertex is look at the shifts. Because there's a -2 on the inside or a -2 on the inside, this is saying to shift right. And this +3 on the outside means that we're shifting up 3. So this is right 2, up 3. And we're going to go to our graph. We're going to go right 2, up 3, which is right here. And I'm going to put a little V here to remember that that's the vertex. So this is 2, 3 for the vertex. Now for a square root curve, a square root function curve like this, you need the vertex, which is here, but you also need an extra point so you know which way you're drawing the curve. Because if you just have one point, how do you know you're curving up, down, backwards, under? You don't know, so you need one more point. So in other words, anytime you're graphing a square root function, you need 2 points. Okay, so we have 1 point down, we need one more to go. So in this case, we're going to use the slope to help us get an extra point. So the slope here, the number in front of this x, is 1. So if my slope is 1, that means I can write that over 1. And so my slope is 1 over 1. So from the vertex, I'm going to go up 1, over 1 to the right 1. And now I am going to do my best to draw my curve. And you can see here, when I start the vertex, I can now know which way I'm curving, and I'm going to put an arrow at the end. Okay, my graph is done. Now I want to go figure out the y-intercept. Now remember, y-intercept is a coordinate and your x value is always 0. So I have to go find that y value. So let's go ahead and do that. So I'm plugging in 0 into my equation. 0 minus 2 plus 3. If I work underneath the square root, I have 0 minus 2, which gives me a -2 plus 3. But hold up. We have a negative in this square root here. So that tells me that this square root is going to give me an imaginary number. Well, if I have an imaginary number, it's not going to appear on my graph, right? So there isn't a, let's see if I can erase that part. So there isn't a y-intercept. So I'm going to put NA, or not applicable. And so what this means is that we shouldn't be seeing any y-intercepts on the graph. And let's take a look at this graph closely. Do you see a y-intercept? In other words, does this curve ever touch the y-axis? No, it doesn't. So we can even see here when we drew the curve, we didn't even have a y-intercept. So in this case, no y-intercept. Now let's move along to the domain. So the domain is referring to the x values here. Looking at this curve here, we can see that the starting x value, or the lowest x value here, is 2 for x. And it's going, this arrow is pointing to the right, so it's going on and on to infinity for the x, positive infinity. So we're going from 2 to positive infinity. I'm going to write that down. 2 to positive infinity, parentheses, and bracket always on the number. So now let's take a look at the range. The range is asking yourself, what is the lowest y value on this curve? And what is the highest y value? Well, based off this curve, the lowest point here for the y is here at y equals 3. The highest y value, well, because this curve is curving up, 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 we're approaching positive infinity. So we're going from 3 to positive infinity. 3 positive infinity, parentheses, and then bracket. And there we have it. We just found all of the components and the graph. And we're done. All right, let's try out number 2 here. So for number 2, we have this function that's also a square root because there is no number here. So this is just a square root function. So let's start by finding the vertex. So that's based off the shifts. So inside the root, we have a positive number, so we're shifting left. 3. And it looks like we have a negative 1 on the outside, so that means down 1. So let's plot that vertex there. So left 3, down 1 is right here. I can put a little v here to remember that this is the vertex. So this is at negative 3, negative 1. Now I'm going to go ahead and plot that extra point because I need 2 points if this is a square root function. So my slope here, which is what I'm going to use to help find the other point, is negative 1. Let me grab a pen here. So because there's a negative sign here, this is going to be a negative 1 for my slope. So slope is negative 1 over 1. So now I'm going to plot that extra point here. I would go down 1 this time from the vertex and over to the right 1 because it's a negative 1. Now I'm going to do my best to draw my curve. You can see this time if I start from my vertex to the other point, I'm now curving down, right? So this time around, it looks like it's going more right, but in the negative region. Actually, let me do that curve just a little better here. So I would be curving down like this. See that this arrow is pointing down and it's getting more negative as it's going to the right. So just be aware of that when we're thinking about the domain and range. Okay, y-intercept here. So if we were to calculate the y-intercept, we got to plug in 0 for x and find our y. So negative square root 0 plus 3 minus 1. Well, in the inside here, I have a square root of 3, and it's a positive, so now I can take the square root of 3. But I'm not sure what the square root of 3 is, so I'm going to need my calculator. So in the calculator, I'm going to punch in, okay, what is the square root of 3? And it looks like it gives me a decimal number. So what I'm going to do is round to the nearest third decimal place. So this is going to be negative. And in the calculator, I have 1.732 minus 1. So anytime you don't know what the square root of a number is, use your calculator and round to the nearest 3 decimal places. 2 is fine as well, but make sure you leave some decimal places. So looking at this, let's subtract now. So negative 1.732 minus 1 is negative 2.732. So that's my y value for this coordinate for my y-intercept. Okay, I have that down. Now I'm going to look for the domain. Domain on this here, if I look at this curve, I want to figure out what's my lowest x value. And that starts here at negative 3 because that's the furthest thing to the left. But as I'm going more and more to the right, I'm approaching positive infinity. So this is negative 3 to positive infinity, parentheses, and a bracket on that number. Okay, range. Range is a little tricky to see here, but I want you to look carefully on this curve. So if you look at this curve, the highest y value is this point right here. Because notice as it goes further and further to the right, it's going down. That means your y is getting really small. Or really negative. So the highest point here is at this point, which is negative 1. So our highest y value is negative 1. The lowest y value, well, because this is pointing down with an arrow, it's approaching negative infinity. So we always start with our lowest, is negative infinity to negative 1. So that's our highest y value, in parentheses on the infinity, and always a bracket on that number, so that negative 1 has a bracket. All right, that's it for number 2. Let's move on to problem 5. All right, now we're on problem 5. Let's take a look at this function here. If you look at this function, this one has a cube or 3 on it, so this is a cube root. Problem 5 through 8 will have a cube root in it, so just be aware that now you're drawing this type of curve. Or sometimes it's backward and it looks like a Z. So a cube root looks kind of like either an S or a Z if it's like flipped. So just be aware that you're drawing this type of curve and not that square root curve. So when we're trying to calculate the vertex, you want to start by figuring out the shifts. So let's go ahead and do that. So there's a -3 on the inside. So this is shifting right 3. And a +3 on the outside. So this is up 3. So right 3, up 3, that's about right there at 3, 3. So I got the vertex. Well, here's the thing. For a cube root, you need 3 points if you want to draw the curve. Just like if you were drawing a cube function, just like in our bell work on Journal 37, you need 3 points for a cube function. So for a cube root, you also need 3. So when we look at this, how do we get the other 2 points? Well, we do it using the slope. So the slope here, the number in front of this x is 1. So my slope is 1 over 1. So I have to go up 1 over 1. Now I have to find the other third point, which is just like doing it with the cube function. You have to go down 1 and over to the left 1. So the reverse direction. So you'll reverse the slope basically. So now I'm going to connect the dots, but you want to be really careful. You do not want to draw your curves like you do with the cubic functions where you curve up and you curve down. You want to curve sideways. So you're going to curve to the right and curve to the left, because now we're drawing either an S or a Z. So just be aware of that. So I'm going to take my vertex and curve this way to the right and curve down to the left. There we go. That's a nice looking curve. So now I'm going to calculate my y-intercept. And just like before, got to plug in 0 for x, find my y. So y equals the cube root of 0 minus 3 plus 3. So if I were to calculate this, so 0 minus 3 gives me -3 on the inside plus 3. Now, this time around, this is a cube function. So a cube function can handle negative numbers. Look at the graph here. If you look at the graph, notice that -3 there, the curve still keeps going on to the negative side. So notice the curve is even showing that it can appear in the negative signs. So we just have to figure out what's the cube root of -3, and you can do that using your calculator. So if you go to math and you hit option 4, on your calculator and you put in -3, I get -1.442. It keeps going on and on, but I'm going to just round it to the third decimal place. And then I'm going to bring down that 3, that plus 3. If I take -1.42 and add it with 3, I get 1.55. I'm going to round to the third decimal place, so 558. So I'm going to put that as my y value. So I have my y-intercept. Now I want to calculate the domain. The domain, if you look at this curve here, this is curving to the left forever and ever and ever. So it's approaching -infinity, whereas the right, it's approaching positive infinity because the arrow is pointing to the right forever and ever. So how do we represent that? Well, we use that R symbol, all real numbers. And let's take a look at the range here. The range, we can see here, this side of the curve, the left side, is going down. So the y values are approaching -infinity, whereas if I go right, the y values are going up to positive infinity. So we're going from -infinity to positive infinity, and so this means that it is also all real numbers for the range. In fact, for all domain and range for cube root functions will always be all real numbers. So if you want to go through problem 5 and 8 through 8 and just put in all real numbers for all the domain and range, feel free to do so. And that's it for problem 5. Let's check out problem 7 next. Okay, so let's take a look at number 7 here, another cube root function. So we always start out by finding that vertex. So we can see here that this is shifting right 1 because it's a negative 1 on the inside of the root and a negative 1 on the outside of root. So that tells me that this is shifting down 1. All right, so with that, that we have the vertex shifts, let's plot that on the graph here. So right 1, down 1 is right here on the vertex. So I'm going to write that as 1, negative 1, it looks like. Now I'm going to plot the other 2 points. Remember, we do that by using the slope. The slope here is the number in front of the x, and it looks like the slope is negative 2. So if my slope is negative 2, I can put that over 1. So I have to go on the vertex down 2 over to the right 1. And then I go the opposite direction to plot my third point. So up 2 over to the left 1. And then I'm going to curve sideways. Remember, we need to curve sideways and not down. So this is curving this way. This one's curving to the left. Okay, I want you to take a look at this curve before we try to find the domain and range. But this curve here, as it's going right, it's getting more negative. It's sloping down. Whereas on this side, as you're approaching left, it's sloping up. So it's getting more positive for the y values. So before we look at the domain and range, let's do the y-intercept here. Let's calculate that. So I'm going to plug in 0 for x and find my y. So this is going to be negative 2 cube root of 0 minus 1 minus 1, negative 2, 0 minus 1 on the inside gives me a negative 1. The cube root of negative 1, if you punch that in your calculator, you will get negative 1. So this is negative 1. So the cube root of negative 1 is negative 1. And then I have a minus 1 out here that I'm going to drag down. Negative 2 times negative 1 gives me positive 2 minus 1, which gives me 2 minus 1 is 1. So my y value here is 1. All right, now I want to calculate that domain. So you guys might have remembered all cubic functions, right, are the domain and range is going to be all real numbers. So I know that the answer should be all real numbers, but let's see why that's the case. If you look at this graph here, this is always pointing to the left, right? So we're approaching negative infinity for the x, and this is always pointing towards the right, so we're always approaching positive infinity. So we're going from negative infinity to positive infinity for the domain, or the x values. So in this case, all real numbers. The range here, this is pointing up as it's going more left. So that's positive infinity for y. And this is pointing down towards negative infinity for y. So the y values are getting more negative. So we're going from negative infinity to positive infinity for the y, so that means it's all real numbers. All right, that's it for number 7. So hopefully this has helped you out a little bit on the homework and knocked out a few problems. So if you didn't watch the Journal 37, please watch that and see if that helps you if you didn't quite understand these 4 problems. All right, take care, guys.